the universe can be quiet, peaceful, still. And then, in an instant, it can unleash explosions so violent they defy all human understanding. Tonight, we count them down. The biggest, brightest, most powerful blasts that have ever happened. And the final one on this list could outshine everything else in existence combined. To measure these explosions, forget bombs. Forget anything on Earth. Our largest nuclear weapons are less than nothing here. We have to measure in the output of entire stars and then keep going far beyond. Let us begin gently with the star we know best, the Sun. Every second, it releases the energy of billions of nuclear bombs in a controlled, steady burn. That is our baseline. One quiet, ordinary star. Number 8 on our countdown. The solar flare. When the sun's magnetic field snaps and reconnects, it releases a burst of energy equal to millions of those bombs in mere minutes. These flares hurl radiation and plasma across the solar system. Aimed at Earth, a large one can spark beautiful auroras and knock out satellites and power grids. And yet, on the cosmic scale, a solar flare is barely a spark. Number 7. The nova. Imagine a dead star, a white dwarf, orbiting a living one. The dwarf's gravity steals gas from its companion, piling it up on its surface, hotter and denser, until the pressure ignites a colossal thermonuclear explosion. A nova can briefly shine 100,000 times brighter than the sun. And because the white dwarf survives, it can happen again and again, a star that explodes on a schedule. Number 6. The supernova. This is where explosions stop being events and start being legends. When a giant star runs out of fuel, its core collapses in less than a second, and the rebound blows the entire star apart. For a few short weeks, a single supernova can outshine an entire galaxy of 100 billion stars. In that one blast, it releases more energy than the sun will produce in its entire 10 billion year lifetime. And a supernova is a forge. The explosion is so violent that it creates heavy elements and scatters them across space. The iron in your blood, the calcium in your bones, the gold on your finger, all of it was born in the heart of an exploding star. One special kind, the Type 1. A supernova always explodes with almost exactly the same brightness. That makes them cosmic measuring sticks. By comparing how bright they should be to how bright they appear, we measure the true distances across the cosmos and discovered that its expansion is speeding up. What it leaves behind is the glowing wreckage of a star, like the Crab Nebula, still expanding 1,000 years after the blast was first seen in our skies. And some supernovae break even these rules. Superluminous supernovae can shine 100 times brighter than a normal one, blasts so bright we can see them clear across the observable universe. Number 5. The kilonova. Take 2 neutron stars, the ultra-dense cores left behind by supernovae, and let them spiral together over billions of years. When they finally collide, the result is a kilonova. A kilonova is up to 1,000 times brighter than a nova, and it does something almost magical. The collision forges gold, platinum, and other precious metals, not gradually, but in an instant. Every piece of gold that has ever existed was made in a blast like this, and these collisions shake the universe itself. They send ripples through the very fabric of space and time, gravitational waves that we can now detect here on Earth from over 100 million light-years away. In 2017, we witnessed one of these collisions in a whole new way. We felt the gravitational waves ripple through the Earth, and moments later, telescopes around the world caught the light of the kilonova. For the first time, we both heard and saw the same cosmic explosion. Number 4. The hypernova. This is a supernova's monstrous big brother. When a star far more massive than the Sun collapses, the explosion can be 10 times more powerful than an ordinary supernova. Instead of leaving behind a neutron star, a hypernova often collapses straight into a black hole while blasting the rest of the star into space. It is the sound of a giant being born and dying at the very same moment. And the very largest stars may die in the strangest way of all. In a pair instability supernova, the star does not leave a core behind. The explosion is so complete that it blows the entire star apart, leaving absolutely nothing. A sun, erased from existence. But the hypernova is important for another reason, because it is the trigger for number 3, the single most violent, most deadly explosion in all of existence. Number 3. The gamma-ray burst. When a hypernova collapses into a black hole, it can channel its energy into 2 narrow beams, firing from the star's poles at nearly the speed of light. In just a few seconds, a gamma-ray burst releases more energy than our sun will produce in 10 billion years. It is the most luminous event we know of. A single burst can, for those few seconds, outshine every other star in the universe combined. These beams are so deadly that if one were aimed at Earth from thousands of light years away, it could scorch our atmosphere and trigger a mass extinction. Some scientists believe one may have already struck our planet long ago. Their smaller cousins are strange in their own right. Magnetars can unleash giant flares that outshine our entire galaxy for a fraction of a second. And somewhere out there, mysterious blasts, called fast radio bursts, flicker across the cosmos, releasing in milliseconds what the sun makes in days. We still do not fully know what causes them. So what could possibly be bigger than a blast that outshines the entire universe? For that, we have to stop thinking about single stars and start thinking about the largest objects that exist. Number 2. The quasar and the blazing hearts of active galaxies. At the center of a galaxy, a supermassive black hole begins to feed, devouring gas, dust, and entire stars. As that matter falls in, it heats to millions of degrees and blazes across the cosmos. A single quasar can shine brighter than its entire host galaxy of hundreds of billions of stars, and it can pour out that energy not for seconds, but for millions of years. Some of these feeding giants fire jets of plasma for hundreds of thousands of light years, reshaping entire galaxies. It is less an explosion and more an eruption that never stops. And when one of these central black holes catches a wandering star, it produces a flare of its own, a tidal disruption event, ripping the star into a glowing ribbon, and briefly outshining everything around it. And now, number 1. The single largest explosion we have ever detected. It happened in a distant galaxy cluster, and it was so powerful that it blew a cavity in space so vast you could fit 15 entire Milky Way galaxies inside the hole it left behind. It was caused by a supermassive black hole releasing an amount of energy so staggering that it is difficult to even write down. It was by far the most powerful single explosion recorded since the Big Bang itself. For years, astronomers doubted the readings. The energy involved was simply too large to believe. It took X-ray and radio telescopes working together to finally confirm that a single black hole had, over hundreds of millions of years, carved a wound in space of almost inconceivable size. Which leaves only one explosion greater than all of these. The one that started everything. The Big Bang. Not an explosion within space, but the expansion of space itself, 13.8 billion years ago. Every atom, every star, Every one of these explosions we have counted down tonight is an echo of that first, unimaginable event. We are all made of the debris of the biggest bang of all. And in the very first fraction of a second, the universe may have done something even wilder, expanding faster than light in a burst called inflation, growing from smaller than an atom to larger than a galaxy, almost instantly. The ultimate explosion from which all others descend. From a flicker on the surface of our sun to a black hole blowing a hole in space large enough to swallow 15 galaxies. The universe does nothing by halves. When it decides to be violent, it is violent on a scale that makes words meaningless. And every one of these titanic blasts happened in perfect, total silence. Because in the vacuum of space, there is no air to carry the sound. The biggest explosions in the universe are also the quietest. Something to think about tonight and get spaced out.